In this class, we will discuss waveguide discontinuities. Under waveguide discontinuities, we will discuss about waveguide irises, tuning screws and posts. This article comes in Unit 5 of Microwave Engineering subject. So let us see what is waveguide irises, or waveguide irises is also called as waveguide windows. Now, generally in transmission lines, the reflections will occur due to mismatch of load. So to minimize these reflections, lumped elements or stubs are generally employed. See, for example, if you take a transmission line, the reflections, if the load is not properly matched to the transmission line, then the reflections will occur. So in order to minimize these reflections, what we will do, we will place a stub, single stub and a double stub. So these stubs will cancel the reflections and maximum power is transferred from the source to the load. This stub introduces a susceptance value. This susceptance cancels out the susceptance, causing the mismatch. Because of this, maximum power is transferred from the source to the load. Similarly, in waveguide also, the reflections will occur if there is any mismatch of load, or if the microwave component is not properly matched to the waveguide, then the reflections will occur. So that means any susceptance appearing across the waveguide causing the mismatch needs to be cancelled out by introducing another susceptance of same magnitude of opposite value. So in the same principle, just like transmission lines, the reflections will also occur in waveguides. So therefore, any susceptance value which is causing mismatch must be cancelled out by introducing another susceptance of equal magnitude with opposite sign. So for this purpose, the waveguide irises or waveguide windows are used for this purpose to remove mismatches in waveguide. So what is the purpose of waveguide irises? Waveguide irises are used to remove mismatches in the waveguide so that the reflections will be minimized. So this is the purpose of waveguide irises. Just the simple point of waveguide irises is to minimize the reflections, to minimize the mismatches in the waveguide. So these are the different kinds of waveguide irises. So this is inductive iris, capacitive iris, parallel resonant iris, series resonant iris. You can see that there is a vertical window. In the iris. That means a small opening, so a small aperture is there in the iris. So this iris is placed in the waveguide itself. You can see this iris is placed in the waveguide itself. So therefore, what is the purpose of this iris? This purpose of this iris is, this iris will introduce some susceptance value. So because of this, mismatches will be removed. So the equivalent for circuit of this iris, because it is vertical, so the equivalent circuit of this iris is inductor. Similarly, the capacitive iris, a small window, a parallel window is opened like this. A opening will be like this. This iris will be placed in the waveguide like this. So this iris will remove the mismatches. So the equivalent circuit of this, because it is just looking like a capacitor. So therefore, the equivalent circuit for this is this kind of iris represents a capacitor. Similarly, a parallel resonant iris consisting of a small opening like this in the iris. This iris is placed in the waveguide itself. So this arrangement is equivalent to parallel resonant circuit. Similarly, you can see the series resonant iris. In this, you see a small opening is, you can observe, in the form of a strip. So this iris is placed in the waveguide. So this arrangement is equivalent to a series resonant circuit. Let us see how the inductive iris is. Let us brief about this inductive iris, capacitive iris and parallel resonant iris in these sections. So what is this inductive iris? The inductive iris is placed in a position where the magnetic field is strong. That means this inductive iris is placed where the magnetic field is strong in the waveguide. So that is the first point. The second point is that the plane of polarization of electric field is parallel to the plane of polarization of electric field is parallel to the plane of iris. Due to this, a current will flow through the iris which causes a magnetic field to set up. So what is the meaning of this? Is that the plane of polarization, for example, the electric field, the plane of polarization of the electric field, the plane of polarization of electric field will be like this. The plane of polarization of this electric field is parallel to this iris. Because of this, a current starts flowing this iris. Because of this current flowing, a magnetic field is set up around this iris. So this iris increases the inductance at that location. So the third point is that energy storage of magnetic field takes place, and there is an increase in the inductance at the point of waveguide iris. So therefore, the value of inductance at this location of the iris increases because of this introduction of iris. What happens because of this introduction of iris? Because of this iris, the inductance value at this location increases. Similarly, coming to the capacitive iris, the capacitive iris is placed where the electric field is strong. Similar to inductive iris, where the inductive iris is placed where the magnetic field is strong. The capacitive iris is located at a location where the electric field is strong. The second point is that the potential which existed between the top and bottom walls now exist between surfaces which are closer. Due to this, the capacitance is increased at the point of iris. Let us see what is this. For example, so when there is no iris, the potential that is appearing across the top and bottom walls now appears between these two surfaces which are close to each other. Now the potential existing between these walls now exists between these two surfaces of the iris. Because of this formula, what is the capacitance formula? C is equal to A epsilon by D. Because the distance is reduced because of this iris, the capacitance value, because the distance is decreased, now the capacitance is only between this. So because of the distance is reduced, the capacitance value at the location of the iris increases. So this is what you have to write. So the capacitive iris is placed at the location where the electric field is strong. Because of this introduction of iris, the capacitance value at the location of the iris increases. Similarly, coming to the third one, this is the parallel resonant iris. So this parallel resonant iris, see here the parallel resonant iris, for dominant mode, this iris presents very high impedance and shunting effect for this mode is negligible. For example, if the dominant mode is propagating, through this guide, so then this iris presents very high impedance. Because of this, there is no shunting effect of this iris for the dominant mode. That means the dominant mode will propagate through this iris, whereas this iris suppresses all other modes. This iris passes only the dominant mode and this iris suppresses all other modes. So therefore, this iris is considered as a band pass filter. This iris is treated as a band pass filter which suppresses unwanted modes and passes only the dominant mode through propagate this guide. So again, this is the series resonant iris. The equivalent circuit of series resonant iris is this. So therefore, this is the first waveguide discontinuities. It's a very, very important question. In the waveguide discontinuities, first we will discuss. We have discussed what is waveguide iris. What is the purpose of waveguide iris? The waveguide iris is to remove the mismatches in the waveguide. So these are the different kinds of irises, how these are placed in the waveguides, and the equivalent circuit of each iris is shown in the equivalent circuit. So this is what you have to write for this waveguide irises are windows. Thank you.